everybody, this is Jen Hackley, and I wanted to first just remind everybody that if you have any questions or comments, to please contact me at that information up above. The easiest way to do it is probably to send me an email, and then I will get back to you and we can talk about times where we're both available to talk either on the phone or via Zoom. Alrighty, so today we're going to continue on our study of mathematics with students in the grades K through 12 by talking about algebraic thinking. Okay, we're moving from patterns, which kids start in kindergarten, all the way up to mathematical representations such as graphing, solving equations, and using tables, that sort of thing. Okay, so today, the first thing I want to do is give you a little tour of the many Virginia Department of Education resources. There are a lot of them there for us to use. After that, we're going to talk about the progression of algebraic content in the SOLs, and then the process standard of mathematical representation. Once that's done, then I'm going to have you get to work on some math, and that's like my favorite part. I think I mentioned to you before, I'm a total math nerd, and I just love talking about all things math. So anyway, let's go ahead and go to the website for Virginia Department of Ed so I can show you all these great things. Okay, so if you go to Virginia Department of Education and then click on Teaching, Learning, and Assessment, and then scroll down on the side, down all the way down to Mathematics, under Standards and Instruction, you're going to find a whole bunch of stuff. Okay, it's also listed right here on these yellow boxes. So first and foremost, the standards of learning and the curriculum framework. So the standards of learning are the state required standards. I'm sure you know that by now. And along with that are curriculum frameworks that give more detail than what the standards of learning say. In addition to that, my favorite part is the instructional resource page, because here there is so much stuff available. If you're not familiar with how to teach a certain concept, there's videos here that help you. There are all kinds of things. So under mathematics, just look real quick, Algebra Readiness Initiative, that has all kinds of pre-algebra stuff in it to help kids get ready for algebra later on. Bridging for the Math Strength website, that is a new one that came up throughout COVID to help find out where the gaps of learning are for students and helping them make the bridge, the cross from one grade level to the next. All right, if you need it, also here there's a correlation between the Virginia SOLs and the Common Core, CCS, state standards, and it helps to make sure that, like, if you're having documents or resources that you're using that are made for CCS, then there's a crosswalk to help you to see how that applies. And then Desmos Online Calculator and related resource. Desmos is the calculator that's used in Virginia testing, so strongly encouraged to have your students using it in class. Here's a whole bunch of information. There's also a lot of good activities, and I'll be showing you one of those shortly. Instructional videos. If there's a topic that you just don't quite know how to teach it, doesn't quite make sense, under here you can go to all kinds of things. There's a whole presentation on multi-step problem solving. Vocabulary, ways to use those vocabulary terms students might confuse. You can see here number sense in the lower grades, activities, computation and estimation, different strategies, and it keeps on going to all kinds of resources. Okay. In addition, there's things like additional resources. Here's the videos from the Tidewater team for mathematics education at the College of William Mary, my alma mater. And there's a lot of good videos in there as well. So just helpful things to show how to teach certain concepts that will help you reach more children. Okay. All right, the next one is there's these things called just-in-time quick checks. And quick checks were designed as formative assessments, and they can be used as I've used them as entrance tickets, exit tickets, and then warm-ups when they come into the room, bell ringers. They have them for all grade levels. They even have a thing down here about how to use them, which is helpful. But let's say in grade 7, if I'm working on measurement and geometry, They have it in Word, they have it in PDF, and they also virtual version. They use Desmos a lot and just have it online for people to use. So one of the good things to come out, I guess, of COVID is all the wealth of online resources that there are now. Okay, so on a quick check, it's going to be questions about whatever the topic is. So in this case, it's surface area of a figure. And they're open-ended questions often where the kids have to explain what they're doing and show what they're doing. And they're usually a little more challenging than just the standard straight learning about what you, I guess the basic learning that you need to have. Then underneath of it, there's resources. So the instructional plans that are fully developed, algebra readiness plans that could help. So it's just very well organized and gives you lots and lots of resources and things you can pull from. Okay. See if I want to go anywhere else here for now. Well, I don't know. Just go ahead and look through. You'll see tons of things. The MIP, MIPS, like I said, are fully completed lesson plans that you can use on certain subjects. Again, it's sort of by grade level and then by whatever it is you're talking about. So, for example, let's go get a little higher this time. Comparing fractions and strategies. Again, it gives you a full lesson plan for you to use. And including things like, let me scroll down here, they give you the worksheets and to use fraction bars in this case, fraction circles, just kind of everything you need in one spot. I do recommend that you make sure if you use these that you read through them, because there's areas for enrichment, there's information about remediation, differentiation, that really, they're very, very helpful. So check out the math instructional plans. All right. So anyway, check that out. It will become a very useful tool for you. Now back to the regular scheduled show. All right, so first a few definitions. Algebraic thinking includes recognizing and being able to recognize and analyze patterns, studying and representing relationships, making generalizations. Let me say, what is a generalization? A generalization is when a student can identify a pattern that they can see and that they're able to describe it, and notice that it always repeats, it's always true. So they can take the generalization from this one pattern and apply it to another one. In numbers, it would be like 2 times something always doubles the number. 3 times something always triples the number. Those kind of things are generalizations. Okay, math process goals for students. Math process goals are the overarching things we want our students to be able to walk away with. They need to become mathematical problem solvers. They need to communicate and reason mathematically. They need to be able to make mathematical connections and using mathematical representations to model and interpret practical situations. So all the content we teach them, whether it's addition, solving equations, graphing, angles and measurement, all of those things support our students becoming people that can do these things. Okay, today we're going to be focusing on the 5th one, using mathematical representations to model and interpret practical situations. All right, so mathematical representations. I'm going to take a minute to read this. I'm not going to read a whole lot to you today, but this one's important, and please read along. Feel free to pause at any time to write things down for yourself. So, mathematical representations. Students will represent and describe mathematical ideas, generalizations, and relationships using a variety of methods. Students will understand that representations of mathematical ideas are an essential part of learning, doing, and communicating mathematics. Students should make connections among different representations. Physical, which would be like manipulatives or blocks. Visual, pictures, something written, drawn on paper. Symbolic, verbal, and contextual. And recognize the representation as both a process, something we use to find a solution, but also can be the solution itself, a product. Using mathematical representations to model and interpret practical situations is another part of this goal. And that would include real world problems and problems that model real world situations. Okay. All right, so here's the progression kind of in a nutshell. The patterning, thinking of like kindergarten, first, second grade, when they're using different things to make patterns and repeating them and extending them, all the way through to representing mathematical relationships, with this more the pre-algebra and algebra stuff that they do. Okay. So this document here is called the Mathematics Vertical Articulation Tool. It's a mouthful. But what this is really good for is if you are interested in finding out what the kids had to learn before they came to you, this is the document for you. Okay, I blew up parts of it, which we're going to see in just a minute, from pages 10 and 11, that show what happens from kindergarten up. So here, go ahead and notice, read through these for a minute. Look at the verbs. Look at how it changes from one SOL to the other. So initially, they're sorting, classifying objects, right? Here's the red ones, here's the pink ones, here's the blue ones, here's the green ones, here's the teddy bears, here's the dogs, things like that, okay? Then they move from that to identifying, describing, extending, creating, and transferring repeating patterns. So now they're able to make their own patterns and transfer it from one attribute to another. From there, they extend it. They're going to do one or more attributes. And in addition to that, they're dealing with more growing and repeating patterns. And lastly, in second grade, they're not only just using objects, but pictures and numbers as well. In third grade, okay, again, it extends a little bit farther. They move on to tables included with everything else they've been doing. And then identifying and creating is pretty much the same thing in fourth grade. And then in fifth grade, they move on to describing and expressing the relationship of number patterns. So describing, we've been doing, be writing or talking to somebody about the pattern. Expressing would be adding some symbols into it. So for example, if I have a table and I start with 1, and then the next number is 5, and then 2, the next number is 6, and 3, okay, I did that wrong. So take all the third 5 stuff out, and there we go. Okay, in grades 3 through 5, things continue forward. We're going from identifying, describing, creating, extending, transferring patterns, not just in objects, pictures, and numbers, but also in tables, which is getting closer and closer to more algebraic thinking and organizing. And then in 5th grade, they have to also be able to express the relationship of number patterns. And expressing means to use symbols like +2 or +4 or ×2 or ×3 in order to identify the pattern. And that takes us to 8th grade in algebra, where it now turns into the algebraic terms, but it's still patterns. Functions are full of patterns, Functions are full of patterns, right? And again, they have to be able to connect and go fluidly between, in this case, tables and graphs and equations, or have a table, develop the equation, have a graph, find the equation, find the table, all that sort of stuff, being able to move back and forth between the representations. So that's my quickie overview of that. And now I kind of want to get you into doing the math, because I think we learn as we do ourselves. So when we're doing these activities, again, I want you to be able to represent and describe the math that you're seeing, okay? And we're going to be using various representations. All right, first off, we're going to go to Desmos. Desmos is a calculator for the state, but it also has wonderful activities that are lined up with Virginia Standards of Learning. Okay, so I would like you to go ahead and go to the Desmos link. And this here, a quick overview of Desmos. You can create an account, and from that, once you have your own account, you can assign different activities to students, and then you'll be able to see their progress, what they got right, what they got wrong, what they completed, what they haven't. So if you just assign an activity, once they learn how to do these things, then you can assign it for them to do, as a challenge when they're finished doing something else, or as an extension for what you're learning. A lot of them are directly related to the Virginia SOLs, like they were referenced in the quick checks that I showed you a little while ago. Okay, a lot of them have a teacher guide that comes with them that is very worthwhile to look through and go through it so that you know what you want to do with it. Now you can write notes, it's got questions to ask. I have found these to be very, very helpful. All right, back at this session, over here, you can also do what I'm going to show us for tonight. When you get on, since you'll be in my class, you're going to sign in and the activity will be there under assignments. But a lot of times you can just go to the link and do it yourself. Okay, but here I'm going to do a student preview. Okay, and these are going to give you pictorial representations and ask you to describe them in different ways. So I'm going to kind of just do the first one as an example, and then I'll have you guys will be working on them yourselves too. Okay. All right, in this case, it's asking in what way pattern A is increasing and decreasing. So I'm thinking, well, it's not, right? Each one of them has 3 blocks. There are different angles, they're moving, but nothing is changing, correct? So for me, it depends on how much you want your kids to write, but the number of blocks remains the same in each case. Okay, that would be an explanation. And what's kind of cool is then they could share it with the class, right? If you want to, they could upload an image, they can talk it here, they can get a calculator if they need to type in fractions or whatever, okay? But they can also just share it with the class. So other students' responses, 3 of them would come here so I could see what they wrote compared to what I wrote. Then next it says, all right, you know this, right? So now, what is that going to look like in a table? Well, it's always 3, right? So it doesn't matter how many there are. It showed us in case 1 there were 3, and 2 there was 3, etc., etc., etc. And you'll notice on the side over here, as I'm doing it, it's graphing the points, which I think is very cool. All right. And then from that, what I'm noticing is just y always equals 3, so it's going to be the same thing here. Okay. So there's really no change in between each one, so this is going to end up being a straight line. Right? And to get that, the next thing it says, okay, you got it, now write your function. Obviously, y equals 2 times x is not it because it doesn't go through it. So they want you to just come up with an equation that's going to work here. In this case, it doesn't matter what x is, all right, y is always equal to 3. So that would be the formula for the function, okay, in this case. So I'm describing it using an algebraic equation, so that is done. Okay, and again, you would see other people's responses. All right, so next one is on you. All right, so please work your way through, I think there's 12 slides altogether. We just did 3 of them. And go through and talk about, first verbally, how is this pattern increasing or decreasing? Okay, and then filling in the numbers, which will cause your graph. Just the dots will be plotted, and then you'll work with this equation to try to get it to change and match up with what you think it is. Okay. So work your way through, count carefully, see what you can come up with. Okay. And I look forward to checking it out and seeing what you've come up with. Okay, so stop right here, take a few minutes and finish working on the Desmos assignment before moving on to the next task. On anything, note it down, and when we have our face-to-face meeting, we can talk about them. And I hope you find it interesting to see what your classmates did, so you can go back into that assignment and see what they did if there weren't that many when you were there to begin with. Okay, next one. This one's a paper pencil task, so you'll have time to start it now, but then after that, I'm going to ask you to finish it up and then comment on some stuff about it. All right, this is called tiling a patio. I like this problem because there are many points of access. And what I mean by that is that it doesn't really matter the level of the student. Most students, sometimes with some teacher help, can get access and figure out a way to figure out what's going on. Okay? So for this one, there's this tile patio, and it's got the black part in here. According to the directions, it represents soil in the garden. A lot of kids interpret that as being a black tile, not soil in the garden. But they need to figure out how many white tile, what the pattern is. As it gets larger, what's happening. Okay, so if you start off by drawing the patio 4, patio 5, and then make observations about the patios, it could help you describe larger patios. So what's happening? You can make some observations. You could draw on your drawings, whatever would be helpful to you. Okay. And then from those, can you describe a method for finding the total number of white tiles needed for a patio 15 without making it? So I'm not asking you to draw something, that's got 50 black tiles or black garden spots in the center. Okay. And then from that, can you make rules? Can you come up with rules that would be needed that would work for anything, whether it was 1,000, 10,000, whatever. Okay. And there's a couple things I'd like you to focus on during this. So I want you to try to solve it, but also, what do you think kids would do? Okay. And do you think they'd all come up the same way? Can you think of ways that would be different? Okay. And when you come up with some of those, I'd like you to go to the Google Jamboard, which is right here. Okay. And what are some of the ways? So for example, here, one person wrote building the patios with tiles. Okay. Or making a table was another person's idea. What else could you think would be useful strategies? Okay. And then once you've done that, and you take some time, work through the problem on your own, okay, and go ahead and go back to the Jamboard and go to page 2 or beyond. You may need to duplicate the page so you have room, and share with us your strategies. So for the purposes of this recording, I put down strategies of a student that came from the case study where I found this problem. Okay. And it's described first by drawing, okay, that +6, where that comes from in her work, and then the 2 times the number of black tiles, and her verbal description as well as her formula, which is in this case 2b, 2 times b plus 6 equals w. Okay. So, and then there would be room for other people to do exactly the same thing. Okay, so okay, and then lastly, for this lesson, once you've done all of that, okay, there's a little thing here to make sure people stop and to think about the representations they used. Okay, what did they move from concrete to abstract? Some of the things that we have talked about in this class. Okay. All right, so next steps. So June 8th is at 2 p.m. is our next synchronous meeting. It'll be recorded for those of you that cannot be present. If you have questions, this is a great place to ask, especially if there are questions you think would be good for the whole group. In class, we'll be comparing the way the students, meaning you, represented the problem. And we're going to also look into the case study and analyze the way the teacher orchestrated the lesson, which is going to lead into our future discussions about math talks and questioning. Okay. So your job before the next meeting is to complete your work on the tiling a patio problem and upload your explanation to the Jamboard due June 6th. Okay. And then after doing the problem, not before, after, read through the case study that I've attached at this link and notice the way that students thought about the problem and the teacher questions and moves throughout the case. Okay. Use these ideas to complete this week's discussion board assignment due June 7th, and all of these links can be found in Canvas. All right, that is all I have for now. Those are a few of the references that I used and links to them if you want to get back to them. I look forward to seeing you at our meeting. And again, if you have any questions in between now and then, give me a call. Thank you.